Okay, so this is me, Colin Manning. Some of you met me already before today, some not. That's my email address. When you're sending me an email, just resist the temptation to put in mycit.ie, because your email addresses end with mycit.ie. So lectures are just plain cit.ie. My office is C123C, which is kind of over that way a bit. You may need to know that because I'm the course coordinator for DWeb1 ITM1. So I'm the person that kind of minds you. So I should do things like learn your names and stuff. So I'm your interface to CIT, so if there's a problem or an issue or whatever, I'm probably your first port of call. And at least if I don't know the answer to your question, I could probably find out who does know. Okay? So if you're going to be out sick or whatever, I'm the person you talk to, stuff like that. Okay? Now, this module, Web Development Fundamentals, is one of 6 you've got this semester. If you're in DWeb, obviously it's quite fundamental because it's the backbone of everything you're going to do for your 4 years at CIT. So certainly if you hate this, you may not be, in the right course. But this is a nice enough little module. Most people enjoy it. You see there from the module descriptor, just move that over a bit there, that this module is 100% continuous assessment. Actually, we'll go back up to the top just to point out some of the things you'll see on module descriptors. You have the course code, obviously. This NFQ here, National Framework for Qualifications, that tells you the level of the module. So it allows someone to understand that this is like a basic module, and there's intermediate and advanced. So in 3rd year and 4th year, you might do advanced modules. So you'll do 60 credits every semester, but they won't all be at the fundamental. If somebody did 60 credits for 4 years, but they were all fundamental, we wouldn't consider that a proper degree, for example, in a discipline. It would have been all just simple modules. ECTS here stands for European Credit Transfer System, and this tells us the size of the module, how much work is in this. Most CIT modules are 5 credits. You may come across the odd one that's 10 or something, or a project or a work placement or something. But for the most part, CIT modules are 5 credits each. This allows people from outside of CIT or from outside of Ireland even to appreciate how big this module is. So the level tells you how hard it is, and the credits tells you how big it is. And this gives us then an interoperable system, so that helps colleges to recognize each other's credits and helps people in different countries understand what you've done. So if you were to move to Poland next year, for example, you could probably take these credits with you and cash them in towards a degree there, for example. Okay. Certainly it makes things more transportable within Ireland, but the point is that it makes it transportable across the entire EU. Every module descriptor will have the learning outcomes, and that tells you what the module is about. You see sort of indicative content and things underneath, but that's not as important as what the objectives of the module are. For many of the modules you'll be taking, particularly in semester 1, you could probably sum them up in 2 or 3 words. I mean, this module is making web pages. That's it. We needn't tart it up any more than that. Okay. Students typically go straight to the end of the module descriptor to see if it's see if there's an exam or not. So many of the modules you'll be doing will be 100% continuous assessment. And you can see that here, that there's no exam at the end of this. Some of the modules have an exam at the very end. So some modules might be as much as, or as little as, say, 30% continuous assessment throughout the year, and then 70% of an exam at the end. So I taught a module like that a few years ago. Many of them are sort of 50% continuous assessment throughout the year and 50% in the final exam. And then others are 100% continuous assessment throughout the year. So it varies from module to module. Once you get 40%, you've passed. It doesn't matter where you get that 40 from. So there was a time, a long time ago, where you could do what you want in continuous assessment. You still had to pass the final exam. But if you had a module that was 50% continuous assessment and 50% exam, and you say got, 8 out of 10 in the 50%, the first 50%, well, then you've already passed. So it's happened to me in the past, for example, that where a module had, a 50% component, a particularly good student would say, well, actually, yip-de-doo, I'm done. See ya. Particularly if that student had some other subject that they might be struggling with. They're like, well, I've already passed this, so I'm out of here. Now, that's not an ideal scenario. That's not a good thing to do, because you'd miss out on things. But at the same time, wherever you get your 40% from, once you have it, you've passed. Okay? This module has 3 components. And the first one is worth 20%, and that's supposed to happen around week 5. And then very, very close to the end, there's a 55% one. And then at the very end, there's a 25% component. In the past, that 20% early on was usually a written exam in class. So it's not unusual for the timing and the format of the assessments to vary from what's written down there. So I'm going to meet with the other lecturers teaching this module to other students, and we might come up with a plan and let you know it. But certainly in the past, that 20% one was a written exam. It was just kind of easier and simpler and more straightforward. So the big chunk of work there then is something that will be delivered close to the end of the semester. It's a 12-week semester, so around week 10, that piece of work would be delivered. And then the 25% one then, that's something else kind of altogether. That's been an exam a few times as well, rather than an actual take home and do project. But we'll come to a decision soon on all of those things and let you know everything you need to know. So I don't anticipate any surprises really in this module. We should fairly soon be able to tell you everything that you'll need to know, and you could even maybe progress ahead even a bit faster at your own pace if you wanted. It's that kind of a module. You'll notice also that this module is 1 lecture and 3 labs. That's quite unusual at CIT. Not least because it's more expensive. Because that's, for 2 groups like you, that's 7 hours of my time instead of 6, for example. So that's one of the reasons it's unusual. It's much more expensive. So that tells you that this is a particularly practical module. So this isn't a very theoretical, very abstract module. This is a do-y module. Go and do it. And so you'll be expected to do that. Okay. So we'll have 1 lecture a week with me talking, and then 3 labs a week with you working. Now it's actually going to happen. I'm going to do a fair bit of talking in the labs as well. So usually what will happen is I'll come along with some sort of party piece, and I'll talk maybe about that for 15 minutes, and then you maybe use that or build on that. So particularly in the first 5 or 6 weeks, the labs will be very directed, and that I'll be telling you, okay, today we're doing this. Blah, 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 blah. Now go do that. Okay? Towards the second half, you'll be working on your assignments. And so you'll have a bit more freedom. I'll be less bossy, and you'll just be working away. As with any module, you're going to have to do it. It's you do it. It's not that you sit there and listen, or just turn up, or just mess around on Facebook for the 2 hours of the lab and expect something to magically happen. Different lecturers have different approaches. I'm probably not. I suppose I'm a bit bossy in my expectations, But I don't bother going around telling people to stop messing on Facebook and do some work, like whatever, you know. So I'm not anybody's daddy. Okay. I think this would probably be one of your more enjoyable modules. It's probably one of the lighter ones, in terms of how difficult it is, and also getting to make web pages is kind of cool. And it's interesting how easy it turns out to be. It's one of those things actually that seems really hard until you go and do it, and then you're thinking that's all there was to it. I could do that. So that's good. So any questions on any of that? So any of the procedural stuff or anything? No takers, no? Okay. Let's have a look. So what we're going to do now is just going to talk a little bit about the internet. Now, I know you know what the internet is like, so I don't need to explain that. But we're going to talk a little bit about the origins of the internet, because many of its features and its properties and its attributes come from its history. And so we just want to learn a little bit about the history. So a computer network allows computers to talk to each other. They're connected in some way and they can communicate with each other. And depending on the configuration of the network topology, it can have different degrees of robustness. So if one part of the network fails, if one of the nodes in the network fails, then the things that are like downstream from that may be disconnected from the rest of the network. So if I was to blow up the telephone exchange in Knocknaheeny, I'll probably knock out a lot of the phones in Cork, the landlines. If there was a power failure up there, a lot of people will be without phones. Okay? Now during the Cold War, which was before all of our times, the West, as it was called, was quite worried that the Soviet Union, as it was called, would launch a nuclear attack. And rather than put efforts into trying to avoid these things, they did a lot of research on how one might survive one. And the US military gave money to colleges and universities to develop networks that could survive a nuclear attack. And you see, if you have a network with a single center and all the traffic is going through that, well, if you take out that single point, so if we took out here, I know that's the middle of nowhere, wherever that might be. Maybe that's where they keep the Stargate or something. But if you if you have some bunker there and all your network information is coming in there and out to the places, if you can take out that point, well then, that looks like Miami there can no longer communicate with San Francisco. And so if you had a network where the paths between points, between the nodes, there were multiple paths between the nodes, well, if any one of them was taken out, the rest of the network could keep going. You may be able to find ways around the failure. And that's what the internet came to look like. So we ended up with, if you have multiple paths like from one place to the next. So when you send information from New York to San Francisco, you don't even know how it's going to get there. You just send it on its merry way, and it tries to get from here to there and to the next place. And it might say, can you get me to San Francisco? And it'll say, yeah, you can get to San Francisco from here, and off it goes. If you were sending, 10 pieces of data, 10 photos from A to B, you might find that they don't even all go the same route. And so this gave us then a decentralized global network that no one actually owns. So no one's in charge of the internet really. No one owns it. And the fact that it's decentralized is kind of hardwired into it, which makes it so difficult to shut parts of it down. So if the network was designed to withstand Miami being hit by nuclear weapons, you know, trying to shut down, you know, something in Miami, or using Miami as a point at which to block something can be difficult because the whole network was designed to just kind of route around that. Well, can't go that way, I'll go this way, right? So that makes it very hard to shut things down on the internet and to stop things. So we see that when it comes to people wanting to assert their copyright, you know, rights. That can be difficult. It can be hard to block things, to stop things. Or if you're a government that wants, you know, total control over your population, like say Iran or China, it can be hard for you to, you know, stop things. So in some countries they have re-engineered the internet and have a slightly different way of doing it to make it possible to you know, keep track of people. So you'd find that everything coming in and out of Iran would be going through one point, you know, which could be monitored and switched off. Same with you know, some other countries. So while you could turn off the internet in Syria, you know, for a couple of hours if you had a mind to, you couldn't turn off the internet in the US. Do you know what I mean? Just not possible. There are just so many ways in and out. You couldn't turn off the internet in Ireland. It wouldn't be that hard though, because I mean, you could, because we have so few physical connections to our neighbours. Do you mean? There's probably just, you know, a handful of cables carrying, you know, quite a lot. But anyway, now we often confuse the internet with the web. Okay, the internet has been around since before I was born. But when I was in college, there was no web. Not at least till the very end. I was very lucky. Had there been web when I was in college, I'd have never finished. So the internet is just the infrastructure that all this stuff happens on. So it's the backbone. It's the infrastructure. It's the roads. Okay. The web is just one of the many things driving on those roads. The web is just one service. There are others. Granted, the web is now the most popular and the most, you know, widely used and most useful. But email was around for a long time, for example. So with email, you compose a message on your machine, you hit send, it gets, you know, sent off somewhere, and ding, 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 ding. It eventually finds its way to the computer of the person you addressed it to. So email was around for a very long time. FTP, or file transfer protocol, is something you're going to see. FTP is a system that allows, still does, you to send a file from one computer to another. So I could have a file on this computer. We could have another computer over there. I could set up a connection between the two of them, and then I could copy a file from this computer to that one. So then there'd be one over there as well. And so for a long time, that's how things were done. I mean, the web that we have now kind of has its beginnings in that file transfer protocol. Telnet allows you to log into your computer from a remote location. You don't see so much of that anymore. So the whole bunch of different protocols. And in the future, there may be things we've never considered. So I guess, I mean, Skype is using a whole other kind of thing. So in the future, there may be other protocols, other things running on the infrastructure. But the web and the internet are not the same thing. Now, at the moment, it feels like Facebook is the internet, you know. But I mean, Facebook is on the web and the web is on the internet. Okay? But they're not the same thing at all. Get the distinction? So the internet's really, really old. The web is newish. Now, so hypertext transfer protocol then, that's what the web is running on. Have you heard of CERN? Yeah, CERN is that place in France or on the French-Swiss border where they speed up electrons and stuff and smash them and make subatomic particles and stuff and try and understand the nature of the universe. So you often hear, oh, some place they're doing an experiment that's going to make a black hole and, suck us all into it. And that's CERN. Okay? So CERN was producing a lot of, like many institutions that, do a lot of research, it had a lot of information and data it wanted to disseminate to the scientific community. And so way back, for example, when I was at college, the way to get at stuff like that was you would FTP into their FTP server, and there might be a file there, like a text file that you could download that had a list of all of the research papers that were available there. So you download that, have a look at the things you want, and then you'd FTP back in, and you'd copy down the file, and then you could look at it and print it. It's a sort of pre-web. You could see how it's getting towards the web, but it wasn't quite there. And so this guy at CERN came up with a way of distributing the information that CERN had to share with the world more easily. And so he came up with the first web browser. And so if you wanted to find out about what happens if you smash this particle off that particle, he made it easier for you to do that. That kind of became quite popular. And for quite a while, the web was just an academic thing. Only people in colleges bothered with it. It was a bit of a, I thought it would never take off myself. So yeah, grand, whatever. But then it started to become useful for businesses and things, and sure enough, it's what we have now, the web that we have now. Okay. So it turned out that it was a black hole that was going to suck up all our time in the end. But we have a lot to thank anyway for CERN. Now, so it's important to understand what happens when you look at a web page. There's a couple of things going on. There are quite a few steps, but because our internet connections are so fast for the most part, it all seems instant. But it's not at all instant. There's a couple of things happening, and you need to kind of understand each of the different stages. Okay? So first up, we have a browser. That's a program running on your computer or on your device, on your phone, whatever. And it's a web browser, and that's a program that is capable then of doing this job. If you have kids on a computer, they think the browser is the internet. That's all in there, in the computer, or all in there in your phone. That your phone knows everything. They don't understand that it's just a connection to the web. So it's a program that connects up to the web. And this list used to have on it the first browser, Netscape, but they're gone now. So Microsoft Explorer kind of killed Netscape, but there was a backlash against that, and we got things like Firefox and Chrome and Opera and stuff. So it's kind of interesting to see over, say, 20 years, the popularities of, the relative market shares of the different browsers. And you can sort of see Microsoft's rise and fall. Microsoft sort of missed the boat a bit. Microsoft didn't quite get the importance of the internet until it was a bit too late. Whereas Apple sort of understood digital music and realized that was going to be important before anyone did, and grabbed all that. Microsoft kind of missed the boat a bit. Now, it's still a very, very powerful, successful company, but it did miss the internet boat a bit, I think. So in your browser, then, you're going to have a link. And there are two ways, really. There can be a link on the page that you just click on, but it's also possible, and I'm only saying this because I don't see people do it anymore, you can just go up to the address bar and type in what you want. So if you want to go to the CIT website, you can actually go up to the address bar and type www.cit.ie. I don't see that anymore. In labs, I just see people go to Google and type cit.ie. No one uses the address bar anymore, as far as I can tell. They might as well just take it out of the browser and give us back some real estate on the screen. I've even seen people Google. So, but you can actually go to the address bar and type in the address of the website that you want. Okay? Or you can just click on a link that has it. So with
address bars are search engines now,
actually, yeah, some of them. There was a time that you had the address bar and you had kind of a window for the search engine on the right. And now, if you just type in something in the address bar that's not a proper address, they just assume it's a search. You know. So yeah, that's true. No. So anyway, you have the link somehow, and that's called a URL. That web address, as we might call it colloquially, it's a URL or URI, Universal Resource Locator, and that goes onto the web or onto the internet, and that request works its way to a web server. So a web server then is a special computer that sits there all day just taking in requests for files from people and then giving them back the file that they wanted. So when you look up your timetable online, for example, there's a web server sitting somewhere, a box in a room somewhere, whose job is just to do that. And you say, I want the timetable for ITM1. And it goes, okay, blah, 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 ITM1, that's this file here, and sends you back that file. So web servers just spend all day taking in requests for files and serving them up to people. It's best to visualize a web server as a box somewhere like this, sitting in an office somewhere over there. Now, obviously, Amazon isn't running on, a Dell, whatever. In reality, web servers now are more virtual and more distributed. So the web server may actually be, like in the very, very early days of Google, for example, it might not have been one machine, it might have been 20 machines or 100 machines in an office in California somewhere. Now, the Google server, I mean, it's not one machine, it's thousands of machines spread across the planet, in different places. Similarly, Amazon is not one big, huge machine somewhere. It's thousands of machines spread all over the world. Although probably not in China for various reasons. So things serving the Chinese market might be in Hong Kong, for example. So in reality, the server is a very complex global thing, but just think of it as a box somewhere that sits there all day, getting in requests and then sends back the file. So think of it as being in one place. Okay? So the server then will send back the file that the person requested. And that file is going to be in HTML, it's called Hypertext Markup Language. And so that file will work its way back to the browser, and then the browser will display that page. Okay? If it turns out, now the HTML file is, well, you're only in your second day of computer college, so if I was to say it's a bog standard ASCII file, that means nothing to you. But it's in the plainest possible format. So the way in Microsoft Word you can bring in these images and you can do bold and stuff, and when you save it, it's all saved in one file. You can't do that with a text file. So if there's an image in the web page, there'll be the address of that image in the HTML file. And so the web browser will have to go back to the web server and say, okay, now I want such and such an image. I want, photo3.jpg, please. So it goes back to the web server, asks for that. So now the web server serves up the image, and it comes back. And when the image comes back, then the browser then will lay it out on the page wherever it should be. Way a long time ago, when the internet was really, really slow, you could actually see that happening. You'd see the text, and then the image would start to appear, and then maybe a minute later the image would have, downloaded. And now it's just Bing. It's all very quick, so you don't see those steps. So the image would be separate, for example. Now, it's the browser that decides what the page looks like. And this is something that web designers find very, very hard to accept. The browser decides what the page is going to look like. All you can do is specify as best you can as how you would like it to look. But different browsers are potentially going to do things differently. For the most part, it's fairly standard now, but there was a time when it was very, very different, and different browsers would do things very, very differently. But there's kind of a bit more sense now. But it's the browser that decides what the page looks like. And some people spend hours and hours and hours of their lives trying to force, such and such a browser to get it just right, and that's madness. You just give it your best shot. You specify the HTML as best you can, and then you let the browser do whatever it does with that. So you have to learn to let go a bit and accept what the browser does. If you have a URL that's like, say, there's it's not spelled properly, then that's called a broken link, we call that. They're very bad. You shouldn't have any of those. No. So HTML files are unformatted text files. They're plain text files typically. So that's the simplest kind of text file you can have in a computer system. By convention, the files on the web server end with either .htm or .html. .html was the preferred extension, but Microsoft servers couldn't handle .html. For quite some time, they could only do 3-letter ones. And so you sometimes see those also. Many web servers are case sensitive with the file names. So my page with a big M and a big P is not the same as my page with a small m and a small p. Similarly, mypage.htm is not the same as mypage.html. So it's important, it doesn't really matter what you do, but it's important that you pick away and go with it. The cool people typically do .html and all lowercase and no spaces in the names. Okay. So the URL must specify the server name and the precise location of the file in the directory system. So you see things like http://www.cit.ie/staff/computing/Colin about me.html or something like that in the URL. So any questions now on any of that? Typically, some browsers can display a variety of images, different formats. We should really only consider GIF, JPEG, and PNG as standard. So you can have a GIF or a JPEG or a PNG. Now we might learn a bit about the differences between those image formats later in the module. But they're the only ones we could consider standard. Many years ago there was a plethora of different image formats. And when computer systems weren't connected to each other, it wasn't such a big deal. If you just have a standalone system, you put images in, you come to it, you want them back, it gives you them back. It's only when you started connecting up systems that you started to need some interoperability in terms of your image formats. So GIF, JPEG, or PNG, anything else isn't really acceptable. GIF is a very old format. JPEG is newer. PNG is the newest, but it's not really meant for images on web pages, and they tend to be very, very big. But we'll learn lots. This is my favorite thing, talking about the differences between those. So we'll stop. Now, so web pages are written in hypertext markup language, and that's what we're going to look at in the next class, what HTML looks like. So HTML is the language of web pages. So any questions on anything we've done today? Or anything else? Great stuff, sir. Yes, sir. How should you address me, Colin? I think for all of your lecturers, you can call them by their first name. Who do you have? Do you remember? You know their names? No, in fairness, I would be fairly confident it doesn't matter who they are. You can just call them by their first names. Okay? Any other questions?